Okay, so today you're going to be looking at probability using counting methods. So this is what I was talking about before this unit started, about the fact that this unit includes a lot of material from Unit 2. So if you're having trouble with Unit 2, this unit was going to be hard also. So this is the section of it that's like this. And obviously a lot of people had some trouble with Unit 2. Hopefully you can kind of figure this stuff out and understand it. So here's just a question. John, Ethan, and Alberto are competing with 7 other boys to be on the school's cross-country team. So there's 10 of them in total because there's 7 other boys. All the boys have an equal chance, it's supposed to say, chance of winning the trial race. Determine the probability that John, Ethan, Alberto will place first, second, third in any order. Okay. Now, this is not just how many ways can they place first, second, and third. Okay, it's what's the probability that they'll place first, second, and third. Okay, so what we need to think about here is how many ways can they place first, second, third, and then also how many ways can all the boys in total place first, second, third? Because that's what probability is. Probability is always favorable outcomes oh, sorry, having a little bit of trouble there. Okay, favorable outcomes over total outcomes. Okay, so in this case, favorable outcomes is when John, Ethan, and Alberto are the 3 people who are in first, second, and third order, third place in any order. Okay, so now the number of ways that the total, like all the boys can place in this race is, okay, so the total is just all the boys, so including our 3 is 10, and in this case it really kind of depends on how you think of it. It could be pick or it could be choose. It technically it almost doesn't matter here. It doesn't really matter here because if you pick permutation P, as long as you're consistent, it'll work. And if you pick combination C, as long as you're consistent, it'll work. So let's just, I hear, personally, if I was reading this question, because it says in any order, to me that means it doesn't matter what order they come in, and I would be using C. Okay, so if we're just choosing the top 3, okay, 10 choose 3, and I just do 10 choose 3 on my calculator. Okay, sorry, just give me 1 second. I should have done it in advance, but I didn't. If I do 10 choose 3, I get 120. And then for the boys, the favorable situation for our 3 boys to all make it in the top 3, what that is this is the part I find students have trouble with, but it's that there's 3 of them and we want to choose all 3 of them. So it's 3 choose 3, which if you type that in, you get 1. So here the probability is 1 out of 120. Now let's imagine we picked permutations instead, and we did 10 pick 3 and 3 pick 3, and we put them over top of each other. So if I do 10 pick 3, I get 720, and if I do 3 pick 3, I get 6. Okay, so it's 6 out of 720, which if I put it into lowest terms by dividing by 6 is 1 over 120. Okay, so I do get the same answer, just like I said. Now the difference here is pick, all you're saying is that, like, if Alberta, what are their names again? Sorry, I can't remember their names. If John gets first and then Ethan gets second and Alberto gets third, that's different than if Alberto gets first, and John gets second, and Ethan gets third, and you're counting those each as a different permutation. And it doesn't matter, though, because you're also counting all the boys as a different permutation. So as long as that ratio is still going to be the same, is what's happening here. But to me, and actually a lot of the questions are like this, where it actually doesn't matter what you pick, which is nice. But as long as you stay consistent, like if you're using choose on top, please use it on the bottom as well. And if you're using P, use it on both as well. Okay, so hopefully that makes sense to everybody, that problem. It's a fairly common one. So I want you to be ready to see it. Okay? It's a kind of problem that would definitely be on a test. Okay, this one is tricky, I think, personally. Students often don't really know how to do it when they see it, and they're kind of like guessing in a way, and they end up, not getting the right answer because they're just guessing. So here's the problem. About 20 years after they graduate from high school, Blake, Mario, and Simon meet in a mall. Blake had 2 daughters with him, and he said he had 3 other children at home. I'm making a lot of typos here, sorry about that. Determine the probability that at least one of Blake's children is a boy. Okay, so we have some different situations here. Now this is actually, I don't know, I see students do funny things. So the 2 daughters don't matter, for one thing. Okay, like it just doesn't matter that he has 2 daughters at the school. At the mall with him. That just doesn't matter. That doesn't affect the gender of the kids at home. What he has is he has 3 children. To me, the easiest way to do this question is to do a tree diagram. Okay, so I'll show you what it would look like. Okay, so it's like the first child that he has. Okay, Blake has a kid. And it could be a boy, or it could be a girl, okay? In this situation, these are the 2 possibilities. I realize that that's not always how life is, but that is how it is in our math book, unfortunately. It's a little old-fashioned. So it's either a boy or a girl that we have at home. Now, then he has a second child. So if, say, his first child was a boy, then he has another child. He could have another boy, or he could have a girl. So these represent different pathways. Like he could have boy-boy or boy-girl, or he could have girl-boy and girl-girl. Okay, and then it continues on, right? Like we could, from there, have a boy or a girl, a boy or a girl, a boy or a girl, or a boy or a girl. And these represent the 8 possible ways that he could have children, okay, in this limited worldview. So at the top there, see, some people are asking me about the tree diagram, so I can tell they don't understand them. Like the top there is, if I followed along all the way on the top, right, boy, boy, boy. So that's one possibility. He could have boy, boy, boy at home, or he could have boy, girl, boy. That would be another one. I'm kind of going in order. I should maybe not do that, but that's okay. Boy, girl, boy. Or he could have boy, boy, girl. Okay. Or he could have boy, girl, girl. Okay. Or he could have girl, boy, boy. Like it just, it keeps going like that. So girl, boy, girl. Girl, girl, boy. Or girl, girl, girl. Those are the 8 possible ways that his kids at home could be. Okay? So our total outcomes here is 8. Okay? Our total outcomes here is 8 because there's 8 possible ways that his kids can be. Okay? And the question was, what are the odds that are at least one of them is a boy? Well, how many of these have at least one a boy? Okay, this one does, this one does, this one does, this one does, this one does. I'm just looking for 1B. Yep, all of them except the last one. Okay, the only possible way that he doesn't have a boy at home is if he has 3 daughters. Okay, that makes sense. So it's 7 out of 8. Okay, that's how you would do that question. Okay, which is, it's an odd kind of question. It's done the same way as if you are flipping multiple coins. Okay, so if it's like, how many ways can you get 3 heads? Or what's the probability of flipping for 3 heads in a row? This is how you would do it. You would make a little tree diagram with heads, tails, heads, tails, heads, tails, and you would do it that way. So this is how you do this question. This is one, either this or heads and tails will probably appear in your test. So get ready for it. Okay, this is like again, a very typical kind of problem. Okay, so this one again, also, all these problems are really typical. This one's like, for sure going to be on your test, something like this, okay? And it also often shows up in the departmental exam. So this is a situation. Bo hosts a morning show. To advertise for his show, he's holding a contest at a mall. He spells out Saskatchewan with letter tiles. He turns the tiles face down and mixes them up. He asks Sally to arrange the tiles in a row and turn them face up. If the row of tiles spells Saskatchewan, Sally will win a new car. Determine the probability that she could win. So obviously it's fairly low. But what we need to figure out here, because it's always favorable over total, is we need to figure out the total number of ways that we can rearrange the letters. Okay, so this caused problems on the test for perms and coms. A lot of people forgot that they need to look for repeats. So here we have 5, 6, 7, 8, 9, 10, 11, 12 letters. So 12 goes on top, but there are repeats, so you need to put those in the bottom. So there's 2 S's, there's 3 A's, there are, that's it, okay? So 2, I think, anyway. Am I going crazy? Nope, that seems like it to me. So 12 factorial divided by 2 factorial, 3 factorial. Okay, so that's 12 factorial divided by 2 factorial, 3 factorial. I believe it is 39916,800. Okay, so it's quite a big number. And we've got a nice large number there. So when we're looking at this, okay, the total is that. So that's what goes in the bottom of our fraction. Now what goes on top? Okay, so on top here, what we need to put is how many favorable outcomes there are. And here favorable is spelling Saskatchewan correctly. And this is where a lot of students get confused. But think about it logically. How many ways are there to correctly spell Saskatchewan? There is one correct way. That's the answer. She has a 1 out of 39,916,800. She has a very low chance. So this is a safe contest for him. Extremely low chance. So think about that when we're saying that there's 39 million, almost 40 million ways to rearrange the letters of Saskatchewan, each of those ways is different. Only one of those ways is the correct way. Okay, so it's 1 out of that number. Okay, and that's the probability. You could turn it into a percent, but it would be a really low percent. So I would just leave it as a fraction. All of these questions you can either turn into a decimal, or leave it as, or into a percent, or leave it as a fraction. On the test, I'll usually ask for one or the other, but if I don't ask, it's up to you. It's like your choice. Okay, so if you prefer to just leave it as a fraction, fine. Otherwise, turn it into a decimal. That's also fine. Okay, now this is this one's a tough question. I would say it's pretty hard. So there are 18 bucks, I almost said, in Marnie's spinning class. Okay, so spin class. She's just torturing herself here. The bikes are arranged in 3 rows with 6 bikes in each row. Allison, Brett, Carol, Doug, Erica, and Franco each call the gym to reserve a bike. You'll notice their names are A, B, C, D, E, F. They hope to be in the same row, but they cannot request a specific bike. Determine the probability that all friends will be in the same row with Allison and Franco at either end. Okay, so this is complicated for a few reasons, partly because there's 3 different rows. But all you really need to do with the fact that there's 3 different rows is multiply your answer by 3, because they could do that in the first row, the second row, or the third row. So really, and that's a really big part of this question, is just realizing that even though there's 3 rows, you kind of only have to do the probability stuff with one of them, and then you just need to multiply your answer by 3. Because like they could all be in the first row, and there's this many ways to do that. They could all be in the second row, there's this many ways to do that, or they could all be in the third row, there's this many ways to do that. They're all going to be the same. Okay, so if we have our 6 boxes, because that's how many bikes are in each row, and we have 6 friends. Now they tell us that, and a lot of people had trouble with this phrasing on the test. So Alice and Franco are at either end. What that means is that Allison is at one end, and Franco is at the other. So there's 2 possibilities for this one, and 1 possibility for that one. Okay, because it could be Allison or Franco, and then it's going to be whomever wasn't chosen. Okay, or you can think of it as that between the 2 of them, there's 2 options. Okay, whatever you want to think, but you have to realize that. Okay, so Allison and Franco are out. Okay, now we have D, E, C, B left. So these guys can go multiple ways, right? They can go, 4 factorial ways in there. Okay, which is great. Okay, and then, now this is the tricky part. There are still how many other bikes in this question that we aren't thinking about? There are 12 other bikes. Okay, so the other 12 bikes, which I told you you don't need to worry about too much, but they are there. Need to be considered too, because even though we're worried about A through F, the other people in the class or whatever are also there and are part of our possibilities. Okay, so we have 2. We have 2 factorial, or 2 times 4 factorial, but we also have 12 factorial because of the leftover bikes. Okay. And we times that answer there, we're going to times that by 3. So our ways that are, these are our favorable outcomes. The ways that they can sit in one row, just the first row, is 2 times 4 factorial times 12 factorial. Okay. And we times that by 3 because there's 3 rows. Now the total is just the total number of ways that the 18 bikes can go. So that's just going to be 18 factorial. Okay. So yeah, this is a tough question. Like, coming up with that 2 times 4 times 12 is hard. I would think most people would forget about the 12. The 12 is like, it's just like when we're talking about like the boys and the girls, well, it's similar anyways, not just like, but when we're talking about the boys and the girls and the committees and stuff, remember? And it's like, oh, well, they're picking 3 boys and 2 girls. Or, the questions where it says there needs to be at least 4 girls. Well, if there's 4 girls, then there has to be however many boys, and you have to consider both boys and girls. This is the same thing here. We can't just consider the bikes that are being used by us. We have to consider all the bikes. Okay, and then you type this in to your calculator. I would suggest leaving it as a fraction. If you get it as a fraction in lowest terms, it is 1 over 92,820, which again is very, very low. Okay, so if they just if it was just random where their bikes went, it would be a low chance they'd all be together. So that's how you do that question. That one's tougher than I would give on a test. I'll just say that one's harder than I would likely give. So don't panic. Okay. So the substitute teacher here is going to hand out a worksheet. Just a reminder that I'll be at the school tonight if you want to practice, or if you are still looking to practice for a retest, because some of you should definitely be doing that. Some of you did not pass the test, and I haven't seen you at any tutorials since. I mean, there's only been one, so don't feel too badly, but you should probably come and practice. Okay, this is also a chance to practice since it's the same stuff, so lucky you. Okay, so get going on that worksheet, and I will see you tonight if you're there. Otherwise, I'll see you when I see you. Okay.